Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is the second half of Week 8 discussion answers. So we're on to problem 4 here, and we're doing the same thing that we were doing in problem 3. The only thing is that the data is presented already in a frequency table. So here in number 3 we had each data value listed out, so it was easier to see each data value and list them in order. Now this table shows me that I have 2 5s, 5 6s, 5 8s, 2 10s, and 1 20, which means that I actually have 15 different data values, but a bunch of them repeat. So just keep that in mind. It couldn't hurt to list out all the data values. I did that here for the median right here, so you can see them all. All right, so when I do the mean, I'm just showing that I have 2 5s, so 5 times 2. I have 5 6s, so 6 times 5, plus 5 8s, plus 2 10s, and plus 20 gives me a sum of 120 divided by 15 gives me a mean of 8. So the median, if I cross off till I get to the middle, there's 15 values, so this should be an odd number. So if I cross off the 5 with the 20, the 5 with the 10, the 6 with the 10, the 6 with the first 8, let's see here, where am I at now? Yeah, the 6 with the next 8, the 6 with the next 8. Let me think. 1, 2, 3, 4, 5, 6, 7, 8. The median should be 8. So median 8. All right, that's the one in the middle right there. Okay. And then the mode is the most frequent repeating data value, so that's 6 and 8. They tie. Okay, they show up 5 times. The range is the maximum value minus the minimum value, so I already showed that 25 or 20 minus. Oops, I did that wrong. 20 minus 5 is 15. And then the standard deviation. So we want to go through these steps again, do the table. So I have the data value, and I'm going to do the deviation, which is the data value minus the mean. So the data value 5 minus 8, which is negative 3. Let me fill in this table here. Okay, so now I have all my deviations in there. And then we're going to do the squared deviations. So negative 3 squared is 9. Remember, how many 5s do I have? I have 2, so I got to do 9 times 2. That gives me 18. Negative 2 squared is 4, so I square that deviation, get 4. How many 6s do I have? I have 5, so 4 times 5 is 20. 0 squared is just 0, and so that squared deviation is 0. And then 2 squared is 4. How many 10s do I have? I have 2. So I'm going to do 8, have 8 there. And then 12 squared is 144, and I only have 120. So that is my squared deviation there. Okay, so now I got to add up the squared deviation. So 18 plus 20 plus 8 plus 144 gives me a sum of, I don't even know how to get out of this box here. Sum, I don't even want to be in this table. Sorry about this. Okay, sum of what was it again? 190. All right, then I got to take that sum and divide by the number of data values minus 1. Remember, there are 15 data values. So 15 minus 1. So I'm going to do 190 divided by 14. That should give me 190 divided by 14, 13.57. And then if I take the square root, the standard deviation of that, I got to take the square root of 13.57, and that should give me square root 13.57, 3.68, and that's my standard deviation, 3.68. All right, so final answer, 3.68. All right, now on to number 5, last problem. This is when we're looking at the normal distribution, which is what we learned about in 2.4. So it says females' heights in North America are approximately normally distributed, meaning bell curve, with a mean of 64 inches and a standard deviation of 3 inches. Draw the normal distribution to answer the following question. So I already gave you a curve. What I mean by drawing it is you want to put 64 in the middle, and then you count up by standard deviations, which is 3 inches. So 1 standard deviation above the mean is 67. 2 standard deviations above the mean is 70, and 3 standard deviations above is 73. 1 standard deviation below is 61. 2 standard deviations below is 58, and 3 standard deviations below is 55. They should be equally spaced, but I was having a little bit of issue with Word. When you write this out, just try and have them equally spaced. Now, the empirical rule tells us that 68% of the data is within 1 standard deviation. So 68% of all heights are between 61 and 67. 95 within 2 standard deviations, and 99.7 within 3 standard deviations. So you need that rule to answer these questions. So it says 95% of females in North America are between what 2 heights? 95 is within 2 standard deviations. So if I go 2 below, that's 58. Up to 2 above, that's 70. 58 to 70 inches is the heights that they're between. Because 95% is 2 standard deviations below to 2 standard deviations above. So 95% of all females in North America are between these 2 heights. This one says, give the percentage of women that have a height between 61 and 67. So 61's here, 1 standard deviation below. 67's 1 standard deviation above. So 1 standard deviation below to 1 standard deviation above is 68%. 99.7% of females in North America are between what 2 heights? Well, 99.7 corresponds to 3 standard deviations. So 3 below is 55. 3 above is 73 inches. Give the percentage of women that have a height above 70 inches. Well, 70 inches is 2 standard deviations above the mean, and we know that 95% of the data is within 2 standard deviations of the mean, but we want to know the percentage that's above it. Well, if I know that 95 is within 2 standard deviations of the mean, like from 58 to 70, then there must be 5% outside of it, and 5% and 2 equal tails. If I take that 5 and divide it by 2, I get 2.5%. 2.5% should be above 70, 2.5% should be below 58, but we're asking for above 70. The last one, it says give the percentage of women that have a height below 61 inches. 61 inches is 1 standard deviation below the mean. Now remember, 68% of the data is within 1 standard deviation, so from here to here is 68%. So outside of that, 100 minus 68 is 32. 32% out over here and over here. But if I divide 32 by 2, then I'll know the portion that's below 61. And that's 32 divided by 2 is 16%. So that's it. Good luck. We'll see you next time.